Yeah, so now I'm going to ask you some questions on electrolysis. Let's discuss, okay? So, the first thing I would like to ask you is, okay, now I'm going to show you one beaker, and we have, you can say, we have two gases here, okay? We have two test tubes. This is kind of test tube, and we have chlorine here, okay, and we have hydrogen gas here, and the chlorine gas is there, okay, and here we have sodium chloride solution, and
Mm-hmm.
here we have two electrodes, okay.
Mm-hmm.
This is the plus one, and this we have the negative one. Is it
Yeah,
clear to you? NaCl.
yeah,
This is A. Wait.
it's clear as well.
Yeah, yeah, yeah. So now the electrolysis of sodium chloride solution is an industrial process, okay. So this
Mm-hmm.
diagram shows that the apparatus used in a school experiment. So you see, when you see some bubbles here, okay, you see bubbles here, and we know
Mm-hmm.
that these rods, they are made up of the graphite also, right.
Yeah,
So now one of the products of the electrolysis of sodium chloride solution is hydrogen,
yeah.
right. So now why do hydrogen ions they move towards the negative electrode? Can you tell me that?
Um, it's because okay,
I want to see your reasoning part actually, okay, because
okay.
such kind of questions can be asked.
So
So
if
I,
when the metal is more reactive than the hydrogen, the metal will stay in the electrolyte, and the hydrogen will move to the anode. To the
yeah, that's okay, but why do hydrogen ions, you're correct, but I am asking you, why do hydrogen ions they move to the negative electrode?
because they're H plus ions.
Excellent. So they are positively charged ions, right?
Yeah. So they
Yeah.
move to negative.
Yes, excellent. So now can you tell me, how does a hydrogen ion change into a hydrogen atom? Hydrogen ion change into the hydrogen atom. Can you tell me that?
Okay. So so an ion changes into an atom
Okay.
when it
When
gains or loses electrons. No, that's
gains
when.
or loses, you have to tell one option. You can't give the two both the
Oh,
options. So
okay.
either it is going to gain or either it is going to lose.
Hydrogen is going to gain.
Yeah, excellent. So it is going to gain the electron, and then it forms the hydrogen atom, right? So now the
Mm-hmm.
next part is that in this question you will assess on using, okay, that's the yeah, the electrolysis of sodium chloride solution also produces chlorine and sodium
Okay.
hydroxide, okay. When you do
Mm-hmm.
electrolysis of sodium chloride, it produces chlorine and sodium hydroxide,
Mm-hmm. Okay.
okay. Sodium hydroxide is being produced in industry. The electrolysis of sodium chloride solution can be done in several types,
Mm-hmm. Okay.
okay. So now, like can you tell me how can you do the electrolysis of that, and you have to tell me the advantage and disadvantage also.
Um. Okay.
So otherwise, in this question, basically, if it's a three marker, you have to explain how the electrolysis has happened, right?
Yeah.
I am
Okay.
asking you NaCl. This is the electrolysis of NaCl, right? Which
Okay.
produces this thing. So now you have to use this information to tell me the steps of the electrolysis. So now, okay, can you tell me what happens at the negative electrode?
Um. H plus ions go to the negative electrode.
Are you sure?
Yeah.
Yes, excellent. Why? Because sodium is more reactive than H positive. So sodium is going to stay in the solution, and hydrogen ion will go towards the negative electrode and forms the hydrogen atom, right?
Yeah.
Yes.
Mm.
The second thing, and what happens at the positive electrode?
Cl minus ions go to the.
Excellent, because these are the halide ions, right?
Yeah.
Yeah, so if halide ions they are present, so what happens?
So when they're present, they um what is it?
When they are present, so they are going to get discharged towards the electrode, right?
Yeah.
Yes. So okay, so the next part I'll say is, see when, so now if when sodium iodide, okay, I'm talking about sodium iodide.
Okay.
When sodium iodide solution is electrolyzed, so iodine is formed at the positive one,
Yeah.
positive electrode. So
Mm-hmm.
now I'm going to give you an equation. So you are going to solve that equation, right? So
Mm-hmm.
now if I give you for this thing, it's very easy. Basically, you have to fill here this side and this side.
Mm.
So can you tell me?
Um. So it's two E minus
Excellent.
and
2
two I.
excellent. So it's very easy for you, right? So
Yeah.
now what is formed at the negative electrode when sodium iodide solution is iodide?
Um.
Sodium iodide solution is iodide. Okay, so what is formed at the negative electrode when iodide solution is electrolyzed? Explain why.
Okay.
What
So
will
the
be formed?
negative. So okay, at the negative, it would be um it would be hydrogen.
Excellent, because it's a solution, right?
Mm.
So
Yeah.
now hydrogen will be formed, and can you tell me why?
It's
Because
because the metal is more active. Sodium's more active.
yes, sodium is more reactive than
Hyd-
hydrogen, right?
yeah.
So yes, the next thing I'll ask you is, okay. Let me ask you about the extraction of aluminium. That's also important. You know what are the name the ores from which aluminium is being extracted?
Oh, um, the ore which aluminium is extracted from.
Yes, I told you.
I know. I remember. Um, uh, just a second. I remember it. Called again. Um,
Okay,
um.
just think that
What is it
till
called?
that I'll draw a diagram. I hope you are able
Okay.
to remember that.
Yeah.
Yeah.
Um. Was it bauxite?
Sorry.
Bauxite.
Excellent. Bauxite is the
Um,
ore,
the ore.
right?
Yeah.
The aluminium. What is the formula for bauxite?
Oh God. Um. and bauxite.
Yes.
Al2O3.
Al2O3, right. So
Oh,
now, okay, yeah. And can you tell, okay, I'll ask you one more thing. Wait. Oxygen is formed at the positive electrode, okay? You understood? So, yeah.
yeah.
So now see, I have showed you a diagram that aluminium is extracted from the aluminium oxide. We call it as bauxite using the electrolysis. So now this diagram shows that a cell is there which is being used for the extraction of the aluminium.
Mm-hmm.
Now, if you see this thing, we have electrolyte, okay, and this is oxygen is being formed at the positive electrode, and this is the negative one. Remember, I told you the lining is of carbon when we did
Yeah.
electrolysis of aluminium ore. So that
Mm-hmm.
aluminium is being formed at the negative electrode. So now
Yeah.
this electrolyte, it contains cryolite.
Mm-hmm. Yeah.
Remember what was cryolite?
Um,
It is also an
it was
ore.
another compound because what is it? It has a
Yes,
high melting or boiling point. Was
excellent. Yes. So it
oh
is
yeah,
also a,
aluminium oxide has a high melting point.
yes. So now it is actually one type of a aluminium ore only. It does not have a high. See now. Okay, I'll ask you. This electrolyte, it contains cryolite. Can you tell me why we add cryolite?
Because cryolite lowers the melting point.
It lowers the melting point of the bauxite. Bauxite has a very high melting point, right?
Yeah.
When you add that thing, it is approximately 2000, I told you, degrees
Mm.
Celsius. But when you add cryolite, it gets it
Like
gets
900.
back to around 900 degrees Celsius, which is a huge difference. So
Yeah.
for that we add cryolite, right?
Mhm. Yeah.
Yes. So now, okay. So you can say that it lowers the melting point. Okay. So that means less energy is required to melt it, right?
Yeah.
Yes. So see, if you have a 2 marks question, you are supposed to give two reasons for that. You split the reasons, okay?
Yeah.
You have to make two sentences. So now the next thing is, see, oxygen is being made at the positive electrode. So I'm going to write an equation and you're just going to balance it.
Okay.
Yeah, that I know you'll be able to do.
That would be okay.
Plus, like you have to balance.
And okay. Okay, so it's 202.
2O2 negative, and here what will come?
Is it 4E minus?
Excellent. 4
Okay.
E minus. Yeah. I'm so glad that you have not done any mistake till now. Excellent.
Mm,
So now, okay, the next the part of this only, the positive electrode in the cell is used up during the process.
yeah.
Explain why. I give you 2 marks for this question.
It's used up because wait, it's because okay,
It is,
positive.
yeah. So
Because
basically,
oxygen reacts with carbon to form carbon dioxide.
excellent. So oxygen is going to react with carbon. See these
So you need
electrodes,
to
I have told
replace.
you they are made up of carbon. Okay.
Mm,
So now
yeah.
this carbon is going to react with the oxygen and carbon dioxide will be released.
Yeah.
Yes, so you have to give
Mhm.
this full thing. You can't say that carbon reacts with the oxygen. You have to tell this electrode, it is made up of carbon. So when it comes in contact with oxygen, then what happens? The carbon dioxide is being released. So that is
Mm,
why the positive electrode in the cell is used up during this process. Is it clear?
yeah.
So yeah, let's discuss the one more. See now this question is about the potassium. I hope these are interesting, right?
Yeah.
They're very interesting actually. So now,
Yeah.
okay, this question is about potassium. There is a professor of chemistry, his name is Humphrey Davy. Okay, so that in 1807, Davy did an electrolysis experiment to produce potassium. So now you should know that, okay, potassium is being produced, right? So now
Mm-hmm.
Davy first tried to electrolyze a solid potassium salt to produce salt,
Mm,
to produce potassium. Okay.
okay. Mm,
Davy first tried to electrolyze a solid potassium salt to produce potassium.
yeah.
Explain why this electrolysis did not work.
Oh, it's because it's solid and the ions in a solid so the ions in a solid they can't move around. So it needs to be molten.
Right, so the ions in solid, they could not move basically, right? They are at
Yeah.
their fixed position. So okay, if it is of 2 marks question, you have to at least give two reasons. Okay, in solids
Mm.
they are fixed and they cannot move, whereas in liquid form or in molten forms, the irons they are free to move and they can conduct electricity. So that is why the electrolysis of Davy did not work here. You understood?
Mm.
Yes,
Yeah.
excellent. So the next thing is, see, it is the way they are asking questions. I have already explained you why solid metals, salts, they can't produce the metal, because the reason is this. It is the way they have asked it. Okay, you
Yeah.
understood, right? So
Mm.
now see, this Davy was the first person to produce potassium also. So
Okay.
now this Davy's experiment to produce this new element was quickly accepted by other scientists. Can you suggest why? Can you think
Um,
of why?
but potassium was accepted. Um,
It's a
um,
very general one.
oh, because it had similar properties
No, no, nothing you have
to.
to give that. You can just simply say, because this Davy, a scientist, he got a proof how to get it basically. You
Oh.
understood? Because when he did the electrolysis of the solid one, he
Mm.
could not carry. But when
Yeah.
he did it in the molten, it's just for your explanation, then he could carry the proof. Okay, then when you
Oh.
get a
Okay.
proof, what do? You can perform that experiment in front of others also. It's
Yeah.
just a one mark this thing question, so you can just simply say that he was able to produce the new element, and that was accepted by others because then he had a proof regarding that, he had a status for that. You understood?
Mm-hmm.
Right.
Yeah.
So the next thing is, a student is there and he dissolved some potassium chloride in water.
Oh
So
God.
you understood, in water means it's an
AQA.
aqueous, right?
Yeah.
So now I'm just going to draw the cell. Okay, so
That's
this is the
true.
electrode, and we have this. This is the positive one. Positive electrode is also called
Anode.
anode. So I'm going to write anode here now, and this is our cathode. Okay, and we have
Mm-hmm.
potassium chloride solution here.
Mm-hmm.
So now the question is, uh, the student expected to see potassium metal at the negative electrode.
Mm.
So this one is the negative one. The
Yes.
potassium is supposed to. The student expected to see potassium metal at the negative electrode, but instead saw bubbles of the gas. The first
Yeah.
question is, name the gas which is produced at the negative electrode. That's very easy.
Oxygen gas.
Really? Negative electrode.
Oh yeah, sorry, negative. Hydrogen gas.
Yes, K is there, hydrogen gas is there.
Negative.
So
Mm.
potassium is more reactive than hydrogen. Potassium will stay in the
Mm.
electrode and hydrogen will go towards the electrode. So
Yeah.
hydrogen gas will be produced, right? So now
Yeah.
explain why this gas was produced at the negative electrode and why potassium was not produced. So this is the reason only which I have given you, right?
Mm-hmm.
Why? Because the first thing is, it. See, if it is a two marker, how will you split it? You have to
So
say that hydrogen gas is
metal.
a the ions they are positive, right?
Okay. Yeah.
Yeah. The first point is that, and in the second point you can always say that potassium is more reactive than hydrogen.
Hydrogen. So it stays.
Yeah.
Yeah.
So the next one is, you have to complete and balance the equation for the reaction at the positive electrode.
I don't know. It's, see.
So now if
Oh.
you have this
I don't know. Okay. 2E minus.
2Cl negative, right?
2E minus.
2E minus. This is also clear to you, right?
Yeah.
So last one more question we can do. At least we have done good 5 question practice,
Mm-hmm.
right? It's
Yeah.
easy for you. You can easily do it.
Yeah.
Yeah, and it's interesting also, and I'm telling you, it is scoring also. If you understand the word molten in aqueous solution, it is very quick and easy to score also. So
Yeah.
now let's do okay, now I'm going to ask you a different kind of a question. I'll just draw a cell for you first. So now we have here, we have chlorine gas, and
Oh.
here we have gas A. Okay, this is basically, this is, you can say, there's kind of a porous membrane. You know what is porous membrane? Which has pores and the things can diffuse from one to the other concentration, right?
Okay.
Now from here we put sodium chloride. Sodium chloride is being put here. This is the positive electrode, this is the negative electrode. Okay, and from here the sodium hydroxide solution is being, NaOH, is being coming, right? The first thing, this is the electrolysis of the sodium chloride solution, which produces useful substances. So can you explain the meaning of electrolysis? This is for 2 marks, so you have to at least give 2 points. What do you mean by electrolysis? Can you tell me the meaning of electrolysis? I am not asking related to this particular cell. Now in this question, when they are just asking that explain the meaning of electrolysis, that means you have to give a nice definition for that. Can you tell me? Just a definition. What happens when the electric current is passed between the ionic substance? Hello? 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 So yeah. So now can you tell me the meaning of electrolysis?
No, yeah.
Yeah, just tell me. I'm not asking for the particular cell, but just give me a meaning of electrolysis as a general term.
Okay. So electrolysis is if you need to extract a metal from an ore, you can use electrolysis. So anything. So if
Yeah,
a metal is
that's
too
okay.
reactive,
Yeah, but you can't say particularly the extraction of the ore. Okay, so you have to just say that when an electric current is being passed through the ionic substance. You
okay.
understood? Now, if you see, NaCl is not the ore,
Mm,
right? So now what
yeah.
will you say? So you have to say when the electric current is being passed through the ionic substance.
Yeah.
Okay. So what happens? Now explain what happens when the electric current is passed to the ionic substance. The ions in the liquid or the solution, they move towards the electrodes
Yeah.
where they react and they cause these ionic substances to decompose. So this is what we call it as electrolysis.
Mm,
You understood now?
yeah.
Yes.
And
So now in this diagram, this diagram shows the apparatus which is used for the electrolysis of the sodium chloride solution. Okay. So now
mm,
electrolysis, it produces two gases. It is one is the chlorine gas and one is gas A. Can you tell me what is gas A? Can you name that
Um,
gas?
it's sodium chloride. So, um, Na. So, okay, what gas it produces? It is um
Which gas will be produced?
carbon dioxide,
Really?
oxygen.
Really?
Wait, in the negative.
Yes,
Oh, okay. Oh, the negative. Hydrogen.
hydrogen gas. Yeah, there can't be any carbon dioxide. There cannot be
Yeah.
oxygen gas, because I have already told you that chlorine is being discharged. That means that means halide ions were already present, right?
Yeah. Uh-huh.
So then you can't even think of the word oxygen or carbon dioxide. I have already said positive electrode, chlorine gas is there.
Mm.
Is it clear to you?
Yes, clear.
Yeah. So the next thing I'm going to ask you is is it clear to you? This is very general. You don't have to get confused to this. You just have to see which electrode it is, and then you see what is the substance. If you split, if see this is halide, so definitely halide. It is chlorine will be formed, but here
Mm.
the sodium and out of hydrogen, sodium is more reactive. It is going to stay in the electrolyte, right,
Mm.
in the
Yeah.
solution. If you see, the solution is this one, it has already showed here.
Yeah.
Yes. So
Yeah.
of course hydrogen gas will be formed. Clear?
Yeah. That's clear.
Okay, so the last question we'll say is yeah, we'll just discuss this one. There is an electrolysis can be used to remove unwanted hair from the skin.
Mm-hmm.
Okay, so now I'll just tell you, basically this is the hair. Okay, this is the skin, this is the hair,
Yeah.
and you can say this is the body fluid. Okay,
Okay.
this is the body fluid, this is the hair, and we have a, you can say, this is the negative electrode. That means
Yeah.
we are using a power supply, and we have a positive electrode at the I'll explain you, like we have, this is the negative electrode. Okay,
Yeah.
whatever we are through which we are taking it out, the unwanted hair, and one patch of that we call it as on the person's skin, is that we call it as the positive electrode. They both are
Mm-hmm.
connected to the power supply. Okay,
Yeah.
so the
Mm-hmm.
hair is basically coated with a layer of a gel which contains ions. So,
Okay.
yeah, okay, the hair, you put a gel on the hair, and which is already uh, which has ions in the solution. So the at the positive electrode is connected to the patch of the skin.
Yeah.
Okay, I'm not making a person. I'm just telling you like this. This is the positive is attached or to connected to the patch of the skin,
Yeah.
and the
Mhm.
negative is connected to the hair. This is hair.
Yeah.
Okay, so the
Mhm.
electricity flows through the gel.
Yeah.
Okay, so and it causes the electrolysis through gel, means through the negative electrode, right?
Yeah.
Yeah,
Mm-hmm.
and it causes electrolysis of the body fluid around the hair follicle. Where is hair follicle? Hair follicle is somehow here,
Yeah.
right? Yes.
Mm-hmm.
So now, can you explain why the gel containing ions in solution can conduct electricity? It is very easy. It is just the way they have asked it. It is creating a confusion, but it is very clear in the question itself. Why the,
Because
yeah?
because the ions, when they're moving, they can conduct electricity.
Excellent. So that means the ions, they are mobile. They can move freely, right?
Mm.
The second part of the question says that the body fluid is a solution that contains sodium chloride.
Mm-hmm.
So the electricity causes the electrolysis of a small amount of this solution. This
Yeah.
solution, it contains hydrogen ions that moves to the negative electrode.
Mm-hmm.
So the half equation represents the equation at the negative electrode, that is 2H plus 2E will give you H2. You understood?
Yeah.
Yes. So now explain why this reaction is a reduction.
Okay, what's reduction? Okay.
It's a one marker. Why it is reduction? How will you say by looking at the reaction it is a reduction reaction?
Reduction is gain.
Gain of electrons. Excellent. So that is why it
Yeah.
is a reduction. So can
Mm-hmm.
you complete the half equation for the positive electrode? We have Cl negative and it is going to get converted to Cl2.
Uh, plus 2 minus.
Where plus 2 minus?
What's the
What?
next is CO2?
Okay, Cl2 here.
Yeah.
Okay, that means oxidation has happened, right? You have to
Yeah.
balance it also. So
I
now
was,
it is just that in a few first two three lines they're making the confusion. Otherwise, it is the same concept, right? It
yeah.
is the same concept. So now, anything you want to ask regarding this? Any problem you
No.
have?
No.
No?
No. No.
Okay, so can we start our new topic then?
Mm, yeah.
You can try some questions on your behalf also, and if you have any problem regarding this, please tell me, I will explain you. But these electrolysis, since we covered that, so I wanted to pick up do some questions with you. It is not
Okay.
yeah. So I hope everything is clear to you. So let's start the new topic for today. The topic is the energy changes,
Okay. And it changes.
right?
Mm-hmm.
You wanted to do this one, right?
Yeah.
Yeah. So now, first of all, I wanted to see what you know about energy changes. So can you tell me what was the conservation of energy? What is conservation of energy?
Energy cannot be created nor destroyed.
Yes.
It can only be transferred from one store to another.
So that we call it as the law of conservation of energy. So now,
Yeah.
when the energy change happens, so can you tell me what is the sign for that? Like why this energy changes, why it gets transformed from one form to another? It is not getting destroyed, it is not making, that means all the energy which is in the universe, that is fixed. It
Yeah.
is just changing from one form to another according to the conservation of energy law.
Mm-hmm.
So now, if we say how does energy like how do you get to know that okay there's an energy change?
And when the temperature of the surroundings or the temperature of the object increases or decreases.
Yeah, so basically a chemical reaction has to take place. That
Yeah.
means when a chemical reaction will take place, then there is going to be an either increase in the temperature or decrease in the temperature, right? And
Yeah.
can you tell me those substances which can you can say store good amount of energy?
Um.
You must be using those things also.
Good amount of energy. Um. Your phone.
Sorry,
Your phone.
what is that? Fun.
The phone. Your phone. Mobile.
Mobile, okay. Phone, okay. So yeah, that's also there. Or you can see the batteries. Yeah, excellent. So that is in the phone only, right? So good example. And right, and can you tell me the two forms of energy when we talk about the energy change?
Um. Endothermic and exothermic.
Okay. So now what we are going to discuss is the energy changes in the reactions.
Okay.
Okay, so now whenever a chemical reaction takes place, the thermal energy, okay, is transferred to the or from the surroundings.
Mm-hmm.
You understood? Now, what is a thermal energy? You have to tell me that first.
Thermal energy is heat energy.
Heat energy. So,
Yeah.
so what will happen then?
Heat will be. produced.
Heat will be produced, either it will be released or
Um,
absorbed, right?
yeah, produced
That is
from
in
yeah.
the form of energy. So let's talk about two different type of the reactions, which are exothermic and we'll talk
Mm-hmm.
about endothermic.
Yeah.
See, whenever there is a chemical reaction, the thermal energy is always transferred either to or from the surroundings, right?
Yeah.
Now, how will you get to know? Because the surroundings will become either hotter or it will become either colder,
Yeah.
right? So now let's discuss what are exothermic reaction. So till now from your previous classes you have been studying that exothermic reaction is the reaction which releases energy, right? Endothermic
Yeah.
reaction is the reaction which absorbs energy. Yeah, this is the
Mm-hmm.
simple definition you have been studying right now. But
Yeah.
let's talk about these exothermic and endothermic reactions in the chemical reactions.
Okay.
Okay, so now in exothermic reaction, if you see, the thermal energy, the heat energy is transferred from the chemicals to the surroundings.
Yeah.
Okay, so from the
Mm-hmm.
chemicals to the surroundings. So now, as there is more of the chemical energy, what will happen? The temperature will start shooting up,
Mm-hmm. Yeah.
and if the temperature shoots up, it will become hot.
Mm.
So that means those chemical reactions are exothermic. You understood?
Yeah.
I have already explained you that the energy is not lost, or it is not either it is not lost, you can say, or made. Yeah, it has
Yeah.
to change from one form to another. So now the energy is changing from the chemicals to the surroundings.
Yeah.
Okay, and the exothermic reaction will take place if the temperature of the surroundings it increases.
Yeah.
Okay, so now let's talk the exothermic reaction in terms of products, the reactants and the products.
Yeah.
So now product molecules, they have less energy than the reactants.
Mm-hmm.
You understood?
Yeah.
Why? Because then only they have more energy, so they react with each other to form the products. If products will have more energy, what will happen?
Yeah.
Yeah, if products will have more energy, what will happen? They are going to get transferred to the reactants, right?
Yeah.
Yeah, so in exothermic reactions, you can say the product molecules they have less energy than the reactants, and how much that difference is there by the amount which is being transferred,
Yeah.
right? So
Mm-hmm.
I can explain in one more type. Like, see, if you see most of the exothermic reactions, there is only a small amount of the thermal energy which has been
Mm-hmm.
transferred. When it is
Yeah.
being transferred, the temperature will rise, shoot
Yeah.
up. So now
Mm-hmm.
in that case, the thermal energy is being transferred and the surroundings it becomes hotter.
Yeah.
So there will be so much of thermal energy transferred in the reactant that sometimes what happens is the reactants they catch fire also.
Mm-hmm.
Like, I'll just give you a daily example of the very common examples of the exothermic reactions. I'm not talking about the chemical reactions right now. Let
Combustion.
Yeah, so like if you know about the
And warmth.
hand warmers.
Yeah.
What are hand warmers?
They warm your hands.
They warm our hands. How do they warm our hands?
And there's a chemical reaction takes place in them.
Yeah, there's a chemical reaction which we call it as the exothermic reaction is being taking place, and that transfers the thermal energy into the surroundings, right?
Yeah.
Yeah, so now if you see, basically you can say is um, they have some kind of a reaction. Okay, so now
Mm-hmm.
when you use it, when you hold it, so what happens? It produces heat.
Yeah.
It
Yeah.
produces heat. How? By the change in the energy when you
Mm-hmm.
take it on the hand, Right, so this is a very common example. I'll give you one more example. There is self heating cans.
Yeah.
Now, what is the concept of that? What is the principle of self heating cans? If you see, they are used to provide the hot drinks such as coffee, or you can say hot chocolate. In fact, you can carry food also, right?
Yeah.
Now,
Mm-hmm.
inside that cans, you'll see the food is there and it is being separated by the some layer kind of a thing which has chemicals in it.
Mm.
So now that chemical is generally, that is calcium oxide, okay, and
Yeah.
water is there. So
Okay.
what happened when you press the button, this bag of water, it burst,
Mm-hmm.
or it has been punctured, you can say, and this
Yeah.
water, it gets mixed up with the calcium oxide.
Mm-hmm.
So what happens, they both react with each other, and
Yeah.
it produces heat.
Mm-hmm. Yeah.
So now that heat basically, it you can say heats up the food or the drink. Like if you're drinking coffee, it heats up the coffee. If you want your food to be hot, so it can heat up your the food. So the basic principle is the exothermic reaction. So are you clear with these two examples? Because these two
Yeah.
examples are in your curriculum also. The hand
Yeah.
warmers and the self-heating cans.
Yeah.
Okay, so now let's talk about the chemical, the chemical reactions, you can say. Okay, chemical examples will say of the exothermic only. So let's talk about the chemical one. So now can you tell me what about oxidation? What is oxidation?
Oxidation is a loss of electrons.
Can you tell me in terms of oxygen?
Oh, when you gain oxygen.
When you gain oxygen, when a substance it reacts with oxygen, right?
Yeah.
And then what happens is it produces
Um.
lot of energy, right?
Yeah.
Now I'll give you an example, the oxidation reaction. Do you know the reaction of the respiration process?
No.
Okay, I'll tell you what happens in respiration. See, respiration basically takes place in the cells of the living
Yeah.
organisms. Okay, and what happens in respiration? The glucose molecule, it reacts with oxygen molecule,
Oh, this. Yeah. Okay.
yeah, and carbon dioxide plus water is being formed. What is the
Mm.
formula for glucose? It is
It's H12.
C6H12O6. Now it's clear. When
Yeah.
glucose it reacts with oxygen, gives carbon dioxide and water, and also lots of energy is being released. The thermal energy, the heat energy is being released.
Yeah.
So now can I say that the respiration is a exothermic process?
Yeah.
So that means respiration is an example of the oxidation reaction. So now can I say that oxidation is also an exothermic reaction?
Yeah.
Yes.
Mm-hmm.
So let's talk about the second reaction, the the combustion.
Okay.
Now what do you know about combustion? What is combustion?
Combustion is exothermic.
That's okay, but what is combustion basically?
Oh,
What is the reaction?
combustion.
What do you mean by combustion?
Combustion is when you burn fuels.
Excellent. When you burn fuels. So can you give me an equation for that?
Oh God. Um.
I
Mm-hmm.
heard, oh God.
Yeah.
So yeah, no, I'll tell you. So see, yeah, so it is burning fuels only. So if
Yeah.
you see these combustion reactions, they take place when the substance it reacts with the oxygen again. It is in the presence
Mm.
of oxygen only. But the thing is that they catch fire.
Yeah.
Okay, so now let
Mhm.
me give you an example of a fuel burning, that is, if you know methane.
Okay.
Okay, methane is present in the, can you tell me, natural gas.
No.
Okay, methane
Oh
is
yeah.
present in the natural gas, and this is a combustible reaction. Now, how? This methane gas, it reacts with oxygen, and then it again produces carbon dioxide plus water, and
Mm.
releases lots of energy. At least you
Yeah.
have to remember this: oxidation, combustion, they are under exothermic reaction. So
Yeah.
now we have one more reaction. The third reaction we have, you already know about that, neutralization reaction.
Yeah.
Now, what was neutralization reaction? Last time also you gave me a nice answer for that.
So neutralization reaction is when an acid reacts with an alkali to form a neutral substance.
Okay, and neutral
Um,
substance,
and
and
it's exothermic,
okay, you're saying neutral substance, and anything else? Any other byproduct?
and it produces water.
Right. So neutralization reaction takes place when the acid reacts with the base and it forms the neutral substance. So many the neutralization reactions, they are exothermic reactions, right? Like if you
Yeah.
take an example of acid, you say it HCl is there. Base, we say NaOH is there. So what is going to form? This NaCl plus water is going to form. Now, if this
Yeah.
reaction takes place, what happens is the temperature it increases.
Mm-hmm.
Okay, not very much I'll say, but definitely with few degrees. There it shows increase in temperature. So now that means these are the reactions which this neutralization reaction is an example of the exothermic reaction. So
Mm-hmm.
now this was regarding your exothermic reaction. So in exothermic reaction, what we have covered? Can you repeat once?
Can I repeat what?
Yeah, can you repeat once?
Repeat what? I didn't hear.
Okay, so like what are exothermic reactions? Is it clear to
Oh.
you?
So exothermic reactions is where the energy of the reactants is greater than the energy of the products,
Okay.
and the temperature of the surroundings decreases.
Increases or decreases?
Wait, exotherm.
It increases. See, if you see, I've been telling you everywhere, the temperature it increases. Because
Oh yeah.
heat is,
Sorry.
yeah,
Oh
see
yeah, yeah,
the,
yeah, yeah, yeah.
because heat is
Temperature
going to
surrounding.
release. You're which you're telling me that okay, the energy of the reactants will be more than products and all. That we are going to cover in the different topic. We call it as the reaction profile. Okay, that I'll take
Yeah.
it up there. But for now, what I have been teaching you is you should know that whenever there is an exothermic reaction, there is an increase in the temperature,
Increase. Yeah.
right? And
Yeah.
yeah, and if you see, I have given you two very common examples of the hand warmers and the self heating cans, and I gave you three different type of chemical reactions which are being taken in the which are the examples of the exothermic reaction. Those three chemical equations, those are oxidation, combustion, and neutralization reaction. See, the question can come like that also. They are going to give you an equation and they are going to ask you whether it is an exothermic or endothermic. So you have to see that if there is an oxidation reaction, it will be a exothermic. If there is a combustion reaction, you could see there is exothermic, or if it is a neutralization reaction. It is not compulsory, they are going to give you this reaction only. You
Mm-hmm.
understood? There
Yeah.
can be another example also, but you should remember this, that the neutralization reaction, it shows the exothermic reaction, right?
Mm-hmm.
Now can we
Yeah.
start with the endothermic reaction?
Yeah.
Yeah.
Sure.
So coming to the endothermic reaction, Now in endothermic reaction, if you see, the thermal energy is being transferred to the surroundings, right?
Yeah.
It is transferred from the surroundings to the chemicals. Is it clear to
Mhm.
you?
Yeah.
That means the products, from products it is going back to the reactants.
Mhm.
Okay, so for that the products have to absorb energy, right?
Yeah.
Yes. So what will happen? The temperature will decrease or increase?
The temperature will increase.
Really?
Yeah, and then not of the surrounding, not of the surrounding.
Yeah, the temperature will decrease. You understood?
Mhm. Okay.
Temperature will only increase when you release energy. Then what happens? When you release in the surroundings, what will happen? The temperature will increase. That is
Mhm.
exothermic. But when we are talking about endothermic, that means the temperature, it is absorbing the you can say heat, or the it is absorbing the heat. So what will happen? It is absorbing the energy. So the temperature, when it is going to form the chemicals, it is going to it is going to
Um.
decrease.
Yeah.
Any problem in this? Are you clear with the doubt?
Yeah.
Sure. I hope you don't get confused in temperature increase or decrease, because we have some bond energy numericals in this.
Yeah. Okay.
Okay. So now let's see the applications of endothermic reaction. If you see the
Yeah.
sports injury packs are there. Now what is that used for? It's a cold pack. So
Yeah.
whenever there's an injury to a sports person, just to avoid the swelling, then this cold pack is put there. Now in this cold pack you have water, okay, and water, you can say water with a substance called ammonium. Can you tell me? Ammonium nitrate,
Yeah.
right? So now in this what happens? So when you squeeze the pack, so this water bag is going to burst, and
Mhm.
the ammonia nitrate is going to dissolve in the water. When it gets dissolved in the water, it carries out the endothermic reaction.
Mhm. Yeah.
Is it clear to you?
Yeah.
So it is going to give the endothermic reaction. So that's a very common example. So if in a question you are being asked about sports injury packs, when they are being a cold pack just to avoid swelling, so that is basically due to the endothermic reaction. So that you understood.
Yeah.
Yeah, so just to avoid that swelling. So, to avoid that swelling, that means the heat is going to be absorbed. When you put that cold pack on that, what will happen when you squeeze it? So, the ammonium nitrate is going to the water which is present in the pack, and it causes an endothermic reaction. That means it starts absorbing the heat. When you start absorbing the heat, the swelling will reduce. Okay,
Mhm. Yeah.
you understood?
Mhm.
So, now
Yeah.
let's talk about the chemical reactions. The
Okay.
chemical reaction, like for examples we'll take of the endothermic reaction, are the first one is the decomposition reaction.
Yeah.
What is decomposition?
Um. I don't know what decomposition is.
See, now decomposition means when you have a larger molecule and when you break
Okay.
it into small molecules.
Okay.
Decompose. What do you mean by the word decompose? A big thing is there and you decompose into the smaller ones, right?
Yeah.
Yeah, so general meaning is that. So, like I'll give you an example. If you do the decomposition of the metal carbonates,
Mhm.
so what happens? Like I'll give an example. The copper carbonate is there. Okay,
Yes.
copper.
Yes. Yes.
What is the formula for copper carbonate?
Oh. CuCO3.
Excellent. So now this copper carbonate is green color. So when you decompose this, so it forms copper oxide, okay, plus carbon dioxide.
Yeah.
You understood what is a decomposition reaction? Basically, the
Mm-hmm.
larger molecule is getting split up into two smaller molecules.
Yeah.
Okay, so now
Mm-hmm.
if you split copper carbonate, which is green in color, it produces the black copper oxide. So
Mm-hmm.
now if you see, when this happens, so this happens when it is being heated. You understood?
Yeah.
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 So whenever you heat this carbonate, it is going to break into the metal oxide, and carbon dioxide is being produced. So the decomposition reactions, we call them as the endothermic reaction, because we are using the heat. The heat is being absorbed. You understood? The thermal energy is being
Yeah.
absorbed. Is it clear to you?
Yeah.
See, you must know these examples, because in direct or indirect way they can be asked. The second one we'll do is, if you have reaction of the acids with the metal metal hydrogen carbonate.
Mm-hmm.
Okay, so now you have an equation where, like, I'll give an example. We have citric acid.
Mm-hmm.
Citric acid is what? The acid. Okay, and when it
Mm.
reacts with, you can say, with the sodium hydrogen carbonate,
Yeah.
and if you see, now these reaction, if you put it in the sherbet sweets, what is sherbet sweets? Can you tell me?
Sorry, what are?
What are
So,
sherbet sweets? Sherbet.
oh, the
They kind of produce a poppy sound, if you remember.
yeah, yeah, yeah.
Yeah. Okay. So now if you put it in these acid and the metal hydrogen carbonate, so now they are going to react in the mouth. Okay.
Mm.
So when you
Yeah.
put this in the sweets, they are going to react in the mouth, and this is also a endothermic reaction.
Yeah.
You understood? And
Mm-hmm.
the citric acid plus sodium hydrogen carbonate, it produces hydrogen citrate plus carbon dioxide and water. In this, the heat is being absorbed.
Mm-hmm. Yeah.
Is it clear to you?
Yeah. Yeah.
Yeah. So now if I ask you, okay, if I ask you, uh, what are the examples of the exothermic reaction? Can you tell me?
Of exothermic reaction,
Yes.
the examples are hand warmers, the self-heating cans,
Okay, the
the
chemical
combustion, the
yes.
neutralization reaction,
Yeah.
the oxidation reaction.
Oxidation. And what about the endothermic?
Endothermic was
The
thermal decomposition reaction,
yes.
the sports pack injury.
Yeah, and when the acids, they react
Yeah.
with the metal hydrogen
Metal.
carbonates,
Yeah.
right?
Mm-hmm.
So
Yeah.
yeah, so now if I give you one equation, like, uh, let's finish this topic at least, okay, the exothermic and endothermic.
Okay.
If I give you one equation, like, you have to tell me whether that's an exothermic reaction or the endothermic reaction. The temperature, this, it started at the 21 degrees Celsius and it finished at, you can say, to 46 degrees Celsius.
Mm-hmm.
So can you tell me which reaction is that? The
So
temperature, it started at 21 degrees Celsius and it got finished at 46 degrees Celsius.
that is exothermic reaction because the temperature of the surroundings increased.
Okay, right. So you can make out which type of reactions are those, right?
Yeah.
So now see about the reaction profiles where we use the word activation energy, and
Mm.
the bond energies. We can do that next time. Okay.
Yeah.
Yeah.
Mm-hmm.
So